So today's my topic is based on the plate grider. So in this topic, this lecturing we are going to see on the different types of grider. So generally there are two types of grider has been used in this topic. Uh, one is plate grider and another one is gantry grider. So first we are going to see on definition on the plate grider and where it was used and what are its application. Mainly, the gridders are used in industrial structure where the large span. It's available in a steel structure. It comes under the category of steel structure for using of industrial roof structure. So next, I go upon the introduction. So introduction, a plate gridder is a I-beam section, I-beam build-up form of plate using bolting or welding. So it means that it made up of I-beam. I-beam is nothing but it have a web and a top flange and bottom flange. It's a combination of top flange and bottom flange with a web plate. So this is called the I-beam. I-beam build up section from a plate using bolting or welding. The connection may happen with a bolt connection or may with the welding connections. So generally these type of plate girders are used in the industrial structure. The connection also already seen that the connections made by using with the help of bolt or welding. Next we seen the what are the loads and how it happens and what are the failures may happen in gridders. That's all the things has been discussed in this slide. So the high bending moment and shear forces caused by heavy loads over long run. So mainly the industry structure, it means that it have the large span. When it is a large span, the entire load will be acted. So load will, including here live load, dead load, and one more load has been also included in the steel structure. That is the wind load. Because of the height of the structure, we are using this type of gridders. So when moves to the height, automatically wind load can also acted on a steel structure. So it may causes the heavy load may causes some of the uh, bending. In every factor, there may be a load, there may be a bending moment, and shear force will be acted on a structure. But here the overspan, long span means over a long span means for industrial use only we are using this long span. While it is a short span, we move into the RCC structure. Whereas the long span only we go for the this type of steel structures. So the high bending moment and shear force caused by carrying the heavy load over a long span may exceed the capacity of rolled beam section. Plate girders are used in such a cases. Their proportion can be designed to achieve the high strength and weight ratio. So based on the weight acted on the structure, we have to design the steel structures. What type of steel structure has been used? There are numerous of steel structures has been given in a steel book. So that is ISMB, like that ISLB, ISHB. So somewhat is given in a steel book. So we have to refer that and what is the case is preferred for the suitable for the strength and high strength and weight ratio. We have to use that and go for the design. In a plate grider, it can be assumed that the flange resists the bending. Okay. So we should design the flange thickness. So based on the flange thickness, the weight will resist and it does not undergoes the maximum bending moment. It should resist the bending moment. As for that, we have to design the flange thickness. So and the web provides resist the shear force. The work of flange is resist the bending moment. The work of web is to resist the shear force. For economic design, low flange size and deep webs are provided. So based on the load, based on the things that happen in a weight loaded acted and structure. So for that we use low flange size and deep webs are provided. It's not applicable for all the conditions. So it may differ with the conditions. So these result in webs which having the shear failure mode in a consequences of buckling rather than the yielding. Okay, so it undergoes buckling and rather than the yielding. It means that when we provide the good steel size, good amount of steel, that is flange size and web which we provided, which can resist the buckling and also yield to the high strength. So it does not go undergoes the failure. Okay. So these are the types of plate griders. So here we have the unstiffened. So unstiffened, first we go with the types and then we can see one by one what's the unstiffened and what is the transversely stiffened flat grider and what is the transverse and longitudinally stiffened plate grider. So here there is no stiffened, that is intermediate stiffener. Here the bearing stiffener may be provided. Bearing stiffener is also called as end stiffener. When end stiffener are provided, it gives them strength to the building strength. It means that what kind of strength it can resist the load acting on a building, industrial building. It can resist the load. So it unstiffened means there is no intermediate stiffener has been provided in a unstiffened plate grider. That only is given. So we have the web plate and the flange. Only that I-beam section has been used here. There is no intermediate stiffener has been provided. So that's a definition. It terms as a unstiffened plate grider. So next to transversely stiffened plate grider, it have the intermediate stiffener, then bearing stiffener. Bearing stiffener, which means that we are providing for bearing stiffener is provided, that is a end stiffener which is provided to resist the load which is acting on the structure. Then and next cases we provide in a transverse manner and also the longitudinal manner. Those two type of stiffener has been given as for the section to resist the all kind of load on the structure. So this one is the plate grider. So these are the parts available in a plate grider, that is a shear strut. So here we have the shear strut, and this one is the top flange, and this one is the bottom flange. Then this one is the web. So this is called as web thickness. Then these are all the stiffener. This is web stiffener. So in a then this one is the flange to web fillet welded connection. So this one is connected in the web plate with the flange plate. Okay. So these are the component of the plate grider. So this is the longitudinal stiffener. Then this one is the stiffener. When it is provided in a horizontal direction, that is called longitudinal stiffener. When it is provided in a vertical direction, it is called transverse stiffener. So what's the main purpose of using the stiffener and where you can use it? In all conditions, we cannot use this kind of stiffeners. So first we go on with the where we use these kind of stiffeners. So stiffeners are the members provided to protect the width against the buckling. So the main thing is already we seen that the web and flange plate which resist the bending moment and shear force. So here the stiffeners are used to protect against the buckling of the web. Okay, so it provides he will give the protection to the web against the buckling. Then a thin but deep web plate is liable to vertical as well as diagonal also, but diagonal buckling also protected. The web may be stiffened with vertical as well as longitudinal stiffener. Okay, so here longitudinal stiffener also used, vertical stiffener also used. So it gets the stiffened, and here one word has been used, diagonal buckling which resist by the vertical stiffener only. Okay, so that's why we are providing this vertical stiffener. So based on the loading condition, we are providing these kind of stiffeners. So again, the stiffener can be classified into the following types. So first one is the intermediate stiffener, next load carrying stiffener, next bearing stiffener, torsion stiffener, diagonal stiffener, and tension stiffener. So these kind of stiffeners are used in the industrial structure. Okay, so these are the different types of the stiffeners. Next is we use the different types of bolted connection or either a cover plate or either a welded grider. So here in a welded grider, that is the C type. In welded grider, we have the weld. We have individual top flange and individual bottom flange, which is connected with this web plate. Okay, so top here it is given as a so we can see through this plate, this image, this is the flange plate and this is the bottom flange plate. These are connected with the web plate by using the fillet builder. So here the bolt with the cover plates, the cover plate has been used to connecting the web plate and the flange plate. Okay. So this is the ISA is given. So the steel which we used here is the ISA. So there are based on the it have the different types of sizes as a 100 mm to 100 mm to 75 mm based on the requirement. We are using this kind of plates. Then this is the bolted with cover plate. So here without cover plate, here we having with cover plate. Then this one is the box grider, then box grider with side plate. So then we move to the steps. So what are the steps has been uh, included in this topic. So first the design for a grider, we have to find out this self height of the grider. So how to find out the self height of the grider? So assuming the self height of the grider, that is total factor load which is acting on a structure by 200. So it will be acted in a kilonewton per meter. So then total UDL. So W is the weight which is acting on a structure. So that is UDL, which is also the dead load plus live load plus self weight of the grider. So here there is some condition and criteria has been given in. So we have to find out the self weight of the grider. The self weight of the grider also given. So what kind of grider we have been using. Then next, we based on the loading condition, we go into the shear force and bending moment calculation. So whether we based on the shear force and bending moment calculation, we have to select the type of the steel section. Okay, all the section which comes under the category as per the codal. In codal, it is given in a table 9 IS 456. So that is given that whether the section, sorry, IS 800, whether it is given that it comes under the plastic section or a semi-compact section or a compact section. When B by TF ratio is less than 9.4 epsilon, when it is a plastic section. So in the in rolled steel angle section, we design a structure with a uh, plastic section. So here the section classifications are comes under the determination of optimum depth of the grider by a relation D equal to M by K divided by Fy power 1 by 3. So the 1 by 3 which is take it as 0.33. Okay. So the K we have find out this K equal to D by TW. Then for D by TW which is less than or equal to 67 epsilon, there is no end stiffener is provided and intermediate stiffener are required. When T by TW which is equal to which is approximately 100, intermediate stiffener are not required, only end stiffeners are provided. So as per the depth and the thickness of the web we have to use whether the end stiffener or intermediate stiffener, whatever is required for the structure. So area of the flange will be calculated by using this formula AF, that is area of the flange, then TF is the thickness of the flange. So as per the codal IS 800 2007 class 8.6.11 page number 63, it is available. The minimum thickness is required for the flange plate, and this one is the checking the moment capacity. So this formula is available in a code IS 800 2007. Then check for shear. Once we select the particular steel angle section, we have to go check whether it resists the bending moment, whether it resists the shear force. So that's the steps number 7. It shows that check for shear buckling of web in a simple post-critical method. So these are the steps has been included, and this is the for welded plate grider. Okay. So another one topic also available in the same unit, that is the gantry grider. So it's also one of the industrial structure. So gantry griders also used in an industrial structure. So this is the my topic. Okay, thank you.